right, we're going to do another problem from D6, proofs involving parallel lines 1. Angle TWX and angle UTW are supplementary. Complete the proof that VX is parallel to SU. Okay, so it's given here that TWX and UTW are supplementary, so I'm expecting when we look at the proof to see this as the very first line, and the reason that we're going to give is given. Let's take a look. Okay, there it is. Our statement copied from the problem. Angle TWX and angle UTW are supplementary. They've just copied that from the text of the question, so we're going to say that the reason is given because it was given to us. All right, next one. Measure of angle TWX plus the measure of angle UTW equals 180. Let's do that again. Measure of angle TWX plus the measure of angle UTW equals 180. Okay, so TWX and UTW, we know that they equal 180 from this line right here because we know that they're supplementary. Okay, that was given to us that they're supplementary, and that's what supplementary means. It means that they add up to 180. So we're able to say this because of the definition of supplementary angles. Okay, let's go to the next one. The next one says the measure of angle RTU plus the measure of angle UTW equals 180. RTU and UTW equal 180. Well, I can see that they equal 180 from the figure because they make a straight line. Whenever angles are linear pairs and form a straight line, we know that they add up to 180. So our reason for this one is going to be angles forming a linear pair sum to 180. Now let's look at number 4. Number 4 to me right off the bat looks like they've combined lines 2 and 3 to make line 4. So let's see if we can kind of figure out what they've done here. On line 2, it says the measure of angle TWX plus the measure of angle UTW equals 180. And then on line 3, it says the measure of angle RUT plus the measure of angle UTW equals 180. Because these two expressions are both equal to the same value, 180, we can set these two expressions equal to each other. We can say that the measure of angle TWX plus the measure of angle UTW equals the measure of angle RTU plus the measure of angle UTW. Okay, and the reason why we can do that is because of the transitive property. And specifically, this is going to be the transitive property of equality because we've got an equal sign. All right, so let's go find the transitive property of equality. All right, next one says measure of angle TWX equals the measure of angle RTU. And let's see if we can look at the line above it and see if that's what they use to come up with line 5. Okay, so if I'm looking at the difference between 4 and 5, it looks like they removed the measure of angle UTW on both sides of the equation. They removed both of those, and that's how they came up with line 5. Okay, so what they really did mathematically is they subtracted the measure of UTW from both sides. Whenever we're adding, subtracting, multiplying, or dividing the same number on both sides of an equation, in IXL, we're just calling that algebra. Okay, and then very last statement, we have the measure of angle TWX. Oh, sorry, the very last statement. Line VX is parallel to line SU. Okay, so line VX is parallel to SU. Okay, so if those lines are parallel, I'm going to look back at the previous line and I'm going to go look at these two angles in the figure and see if I can determine what type of an angle pair this is. Okay, so we've got TWX and RTU. TWX and RTU. Those are corresponding angles. Okay, TWX and RTU are corresponding angles. And we know that if we have corresponding angles that are equal to each other, we can then say that the lines are parallel. Okay, so this is like using our corresponding angle theorem in reverse. Normally, we're saying the opposite of that. We say that the lines are parallel and the angles are corresponding, therefore, the angle measures must be equal. But we're doing the opposite of that. We're noticing that the angles are corresponding. We also notice or know that the angle measures are equal because of line 5. So we can therefore say that the two lines are parallel. So the reason for this one is going to be the converse of the corresponding angles theorem. We'll go ahead and submit this one.